We are starting with the techniques of integration, and the first technique that you'll be learning is something called integration by parts. And it comes in this form. So the integral of u v prime dx is equal to uv minus the integral of u prime v dx. So quickly, let's look at an example here. Let's say we want to find out the integral of x e to the x. And of course, if you just try to anti-differentiate this, you're going to have some trouble. You're not going to have a straightforward way to do it. And often when you have a product of two functions of x, there's a high probability that you're going to be using integration by parts. So what we have to do is map each function, so x and e to the x, to either u and v prime. And this is what I'm going to do. I'm going to say that u is equal to x and v prime is equal to e to the x. Now, you need to choose what u is going to be equal to and what v prime is going to be equal to, but the intuition to choosing this, it builds over practice. So now this becomes e to the x, and u prime equals to 1. And now all we have to do is map these into this formula right here. So this is going to be equal to x e to the x minus 1 times e to the x dx. So this is going to be equal to negative e to the x plus c. So that is how we would find the integral of x e to the x using integration by parts. So let's go ahead and try out this example problem here. Show that the integral of e to the x cos x dx equals to 1 over 2 ex times sin x plus cos x plus c. So what we're going to do first is identify what u and v prime is going to be. So in this case, I'm going to choose that u equals to e to the x, u prime equals e to the x, v prime equals cos x, so v equals to sin x. So let's go ahead and integrate this by parts. So this is going to be e to the x sin x minus e to the x sin x, just like that. And now what you see is this other integral that I am also going to integrate by parts again. So in this case, I'm going to say that u equals to e to the x, u prime is also e to the x, and now v prime is equal to sin x, where v is equal to negative cos x. So let's go ahead and integrate that accordingly. So this is going to become minus e to the x times negative cos x minus the integral of e to the x times negative cos x dx. Oops. And let's simplify this. So it'll become like this. And as you can see here, you might think that, we have this integral e to the x cos x, and it seems like we're just going to be falling into an infinite loop of integrating by parts. But no, because of the fact that this integral is the same as this integral. So what you're able to do is actually just move this integral to the other side and combine it together. So this would become 2 times the integral of e to the x cos x dx equals to e of x. And I'm going to factor the e of x out. So it becomes like that. And now we can clearly show that this is going to be equal to 1 over 2 e to the x times sin x plus cos x. And of course, don't forget the constant c here.